Welcome, everybody. My name is Ludwig Lenström. I'm from the Swedish Energy Agency. We are working in India based on a bilateral agreement with the Ministry of New and Renewable Energy and Bureau of Energy Efficiency. One of our main collaboration partners are Confederation of Indian Industry. What we're doing in this program, it's called the India-Sweden Innovation Accelerator. The purpose with the program is to promote technology transfer between India and Sweden, and with a special focus on innovative companies with that share a willingness to develop new innovations adapted for the Indian conditions. And as one example of these companies that we're introducing is Klimacheck. And I now hand over to Klimacheck to give a presentation of what they can provide. Thank you.
Good afternoon to everybody. I really appreciate the opportunity to talk about Klimacheck and the products that we have developed. I hope you can see the presentation now. And Klimacheck is focused on enhancing energy performance in refrigeration and air conditioning systems, and have developed cost-effective portable analyzing system and fixed performance monitoring systems that we work with on the global market. And as you know, air conditioning refrigeration is a very big sector. We have it everywhere in the society, and what surprises many people is that 20% of the global electricity is used by air conditioning refrigeration processes. And in India, we had the information that it's 35% that is used in this sector. And of course, that highlights the focus on making these systems energy efficient, as electricity is in shortage, and it's very expensive to build new plants. And if you can save energy in the existing plants, that is very cost effective. And the air conditioner refrigeration industry has never been focused on energy efficiency due to that the equipment owner normally are satisfied if the temperature is achieved. So wherever you see surveys on the efficiency, you can find that there is a huge saving that is possible to achieve in existing systems without major investments. And in air conditioner refrigeration system, they normally never reach the factory efficiency due to that nobody pays attention to optimization. When you start a system, everybody's happy if it cools the temperature, and then as the system operates, there are many things happening in the systems, and gradually the performance decreases. And at some point you reach a critical situation where you will have failures in the system within short, due to that the stress on the system increases when efficiency decreases. And there are many quite simple problems, and we find them everywhere. Globally, it's the same simple problems that you find in the system, and where they have not been properly checked. And this is a survey that was done on 164 inspections, where the contractor knew that there would be an inspection. But in spite of that, there was only 30% of the system that was performing as people thought. trying to change. So in any optimization starts with measurements. If you don't know how it works, you cannot improve it. And there have been no methods on the market that have shown the actual performance on site. So they've been very challenging. And ClimaCheck has developed a method where we can, with a portable system, in 20 minutes hook up and show the performance, the COP or EAR, and the cooling capacity with good accuracy. And also, of course, you can use this method permanently on the systems. And currently, there's more than 1,000 of our analyzing systems in operation around the world. And the basic method for a standard system is that you connect two pressure sensors, the same high and low pressure that is used for any surface. There are 7 temperatures that you apply with surface mounting on the tubes. And then you connect the electrical voltage and currents. So here it is shown in the flow chart where you connect on the discharge of the compressor, the suction of the compressor, and the liquid line. And for references, you need to know what temperature condition the condenser is working and what temperature conditions the evaporator is working, and then the active electrical input. And when we have this information and refrigerant properties, we can calculate the enthalpies of the system. And this gives us where the heating capacity and cooling capacity and the COP of the system. And the trick is that we can use the compressor as a mass flow meter when we know the power input and we know the enthalpy difference of the compressor. Then we also know the mass flow of refrigerant, and that gives us a possibility to calculate the capacity. Then it becomes a question of showing this data for the refrigeration air conditioning expert or the technician to be able to interpret and see what could be improved and what is not as it is intended to be. This is an example from one of our customers, which is Carrier in Europe, where they measure the performance with ClimaCheck, and then they enter the operating conditions, that means the water temperatures on this chiller, and their software gives the nominal data that the chiller is sold to produce. And you can see the deviations. In this case, they are very small. And the nice thing with this is that the performance that ClimaCheck calculates does not include any carrier information whatsoever. It's just the thermodynamics and the first law of energy. And there are many advantages with measuring on the refrigeration process. I mean, it's a very well-defined system, and the properties of the refrigerants are well known and defined. And you can connect it in 20-30 minutes, and this method becomes very insensitive to measuring errors. It's not like when you measure on the water side, where you have a few degrees temperature difference, which makes any error very, very significant. And another advantage is, of course, that you don't only see the total performance, you also see the performance of all components in the system, which makes it much easier to see what's happening. And if you do some changes, you can immediately see the improvement in the system. And of course, it's nice not to have to use any manufacturer data for the system. And this becomes a very efficient tool for optimization and early warning. If, for example, your compressor is losing isentropic efficiency, you know immediately that you need to deal with that. This is just an energy optimization project that was done on 6 Carrefour supermarkets in Italy, where they mounted the climate check equipment for fixed monitoring, and then they worked systematically to optimize the controls of the systems and correct errors in systems. And they reduced their electrical consumption with 23%, which in this case corresponded to 318,000 euro per year saving, which was much more than the total installation cost. They also could identify 9 out of 90 compressors that could be repaired rather than as traditionally in one field failure. And the repair cost of a semi-automatic compressor is typically around 10% of if you run it to a total failure. This is an example from a survey done on new systems where there were commissioning inspection was done by a third party, and you can see that there is a big deviation already on these systems in spite of them being new. So some systems are using more than 30% more than what they are sold to do. And of course, working with energy optimization, it's a great business opportunity for the end users. If they can use less energy, they become much more competitive. And for contractors and consultants focusing on energy efficiency, there's a lot of business opportunities. Although the market in air conditioning refrigeration have not been focused on this, I think there's a great and increasing interest from their users to reduce their energy costs. And I mean, as I described, what we do is we open the black box. Traditionally, nobody had looked at what's happening inside the process. People have pressure gauges or pressure sensors, they have temperatures, but they do not have the performance online when they check the systems, which makes it very difficult to optimize. So, as I mentioned, we have experience from all around the world, and we find the same situation everywhere, that there is a lot of inefficiency in the systems. There are some examples here. In Macau, that's the biggest cooling center in the world with 150 megawatt cooling on chillers. And so that is the large end. And then you can measure with the same equipment also small split systems. This is one example where a chiller was evaluated, and it could be identified that the part load performance of the compressor was really poor. So the part load efficiency of the compressor is about 47%, whereas at full load it's about 65%. And if you draw the conclusion of this, and you have 8 compressors, you don't need to use the part load operation. So it could just be Okay.
Or your connection was lost.
Okay.
Re-establish.
Obviously, we had some internet connection issue, but it seems to be okay again. So, as I mentioned, the supermarket is another sector where we measure on many systems around the world, both the traditional ones and then to the right is actually a supercritical CO2 system, which is the latest development in supermarket refrigeration. And this case is supermarket in Italy, where they measured over one night when they mounted a fixed installation, and then they could adjust the control settings, and they could improve the COP with 27%. And when you're using permanent monitoring, of course, you get also the energy statistics, where the yellow bars here, they correspond to the consumed kilowatt hours, and the curves, they show the expected consumption. And when you work with optimization, you can see very clearly, visualize the result, where you can see that the difference between the yellow bars and these curves, they relate to the energy saving. You can also detect things like refrigerant leakage, where you can detect deviation from the expected consumption. When it starts increasing, you can send somebody out and fix it rather than continue running for a long period of time and have the problem when you get the hot day. You can also collect all your systems and have a panel where you can see where there are red or yellow lights that are systems that need attention. Also, for very complex systems, you can apply the method. It just requires a little bit more sensors, but you can apply the same thermodynamic evaluation on large ammonia plants, for example. And this is an example from an ice rink in Canada, where you can also again see how they systematically work with optimization and achieve significant savings on the energy. We also supply quite a few manufacturers using it in their development test rigs and their production test rigs, and also for after sales. I mean, it's very expensive for manufacturers to have problems in the field when the contractor and the end user is not satisfied with the product. If you have access to the clean check information, you have the same information as you have in a test rig in a factory. So it's very easy to pinpoint any problems and know if it's internal in the system or if it's outside of the unit. And today, I would say that the method is well accepted in Europe and also in North America. We work with NREL, for example, which is a national laboratory working with energy efficiency, and many of the global leaders in the industry is using our systems for evaluation of systems. Like Copeland is using our systems for their application engineers to when they're working with their OEM customers producing units, and DuPont is using our system to do field tests with their new refrigerants. So it's many of the well-known have tested our system in their test rigs and verified that we can give very accurate data. Okay, that was a very quick introduction to ClimaCheck, so I would be very happy to, if there are any questions.
Shall we? Please advise the best.
Totally. There was a question on code generation, which is not something that I'm have any expertise in. So that question I would not be able to answer. Are there any other questions regarding efficiency on air conditioning and refrigeration systems? Okay, then code generation. Okay. I'm not thinking we should leave on that.
Thank you.
Okay, if there is no questions or any comments that anybody would like to share with the audience? Okay, so okay, thank you very much for the comment from Nurali Raka, who said it was excellent. So then there is a question, please show project implementation regarding its operation and economics. So the question was, please show project implementation regarding its operation and economics. I think that I showed some examples of where it frequently is possible to save 20 to 30% of the electrical consumption of the plant. And then the payoff time is only a few months because of the cost of running, example, chillers or supermarket are huge versus the cost of analyzing the system. So typically payoff time will vary from a few months to a year, or means sometimes if the savings are small, it could be 2 years, but it normally is very cost effective to analyze the system and optimize it. But the savings, they are of course coming from what you do with the results, not with putting on a measuring system. It's the optimization that you can do when you know the details of the system that creates the saving. Then there is another question, what is the optimum size of a refrigeration unit for this tool to be suitable? And this is a question, I would say that obviously it's possible to measure on domestic appliances. We sell equipment to those that are developing domestic appliances, but it's not cost effective to measure on these systems in the field. But even for small split air conditioners and rooftop units, to do it on a regular basis, the service where you actually document the performance costs minimally more than a traditional service. So the additional cost is well worth to take to avoid that system are operating inefficiently for a long time. And of course you would reduce the number of failures. You reduce the number of failures drastically if you find problems when they are small problems before they become critical, so the system fails. And I have a question on if there is any implementation of ClimaCheck in India. And yes, we have, there's one manufacturing facility in India that Reynolds up in Haridwar that is using ClimaCheck for their test their systems before delivering them. And then there are a couple of portable systems used for energy optimization in the field. Then we have a question. We have 10 split ACs of 2 tons each in a hall. Will this tool be suitable and cost effective? Absolutely, it's cost effective to use clean checks when you do maintenance on these to increase the quality of the maintenance, to be sure that you catch any problems and have them operating at maximum efficiency. And then there's again a question on return on investment for the product. And the challenge is maybe to answer that question is that you don't know how efficient the system is before you have measured it. So to do the calculations, you can do it on a statistical experience, and it's very unusual that you cannot save 10%. And all the surveys that have been done and the cases that have been documented, the savings are between 20 and 30%. And then the return on investments for chiller plants and supermarkets, so we're talking about none. Okay, so then we have a question where they have sophisticated EMS systems to monitor for screw chillers. So the question is, so how does our product fit for this job? As I mentioned, we are supplying Carrier with our systems in Europe, and they use it both with their new products with the most sophisticated control systems, and it's a very big difference from the control systems information where you can see the pressures, you can see the temperatures, but you do not have any you don't have any information on the actual performance of the system. So it's very challenging to use the pressure and temperatures to optimize the system, whereas if you are using our system, you would see the compressor efficiency, you would see the heat transfer performance of the evaporating condenser, you will see the flows and how it impacts the total performance of the system. So if you change the flow, you will actually see the change in performance, which of course create a much more efficient tool for optimization than if you just look at pressure and temperatures. Of course, the information in one way is there in a control system, but it requires a lot of engineering hours to calculate what it means in performance. Obviously, there are some issues for some of the audience to hear my voice clearly, or maybe my English is not very clear. So it's a question if I can reply in mail, and obviously I would be very happy to reply on any email questions, and so just feel free to send me more questions, and you can find find my address and contact information on the web platform for the Innovation Accelerator. And then there come question, can you share data sheet for the product? And absolutely, if you send an email to me, I will send information. And you can also look at our website, www.klimacheck.com, and there will be quite a lot of information there as well. Okay, thank you very much for the attention, and I will turn the microphone over to Ludwig again.
Thank you, Klaus, for this presentation of the technology from ClimaCheck that allows for optimization of cooling systems. It's possible to reach ClimaCheck and also other companies in the program India-Sweden Innovation Accelerator. The web page, we have a web page where you can find all the relevant information of the companies, the technologies, and also, of course, contact information. And now we continue with another company. It's the company Opcon. They have a lot of solutions related to combustion and flue gas cleaning. And I hand over the microphone to Christopher Rehn from the company Opcon.
So, thank you, Ludwig. I will give a presentation of the company Opcon, another technology developer and supplier from Sweden. My name is Christopher Rehn, and I'm working with strategic development for Opcon, and we are looking into India as a very interesting market for the future. Within the Opcon, we are doing several different technologies. It's about turbines for electricity production. It's about compressors for different purposes. It's about flue gas condensing and cleaning, and also about full-scale bioenergy plants utilizing bioenergy in different aspects for heat and power production. And it's also about material handling, for example, for the bioenergy plants. Today we are situated in Sweden, Germany and UK, and has so been for a long while. But we are also having partners worldwide, where I hope that India will be one new country where we will have new partners. We have a long experience since 100 years ago with developing and industrializing technology and systems for resource-efficient energy consumption. And I will show you a picture here about what we have been doing in the past that also will give you an idea what this can mean for the future. Back in 1908, we were doing the first double-rotating steam turbine, and that increased the efficiency for a steam turbine with 20 to 30% approximately. After that, we were doing the air preheater that was installed on almost each and every coal power plant in the world. And that was also sold on licenses, so it was developed in Sweden, but then produced and sold in different countries around the world. This increased the efficiency on a coal power plant with also 20 to 30%. We have developed the double screw compressor that is used in almost every compressor. For example, from Atlas Copco today, they are buying technology licenses from us for doing this, and also in a lot of other compressors. And with this double rotating screw compressor, we have also developed other utilities, like the Opcon power box that we will focus on for now, that we think will have a great impact on the reduction of energy in the future as well. And I will show you a little bit more about the Opcon power box here, what it is about. With this Opcon power box, we can use waste or excess steam or heat for power production. We recover the waste steam or heat, and then we're doing electrical power with the Opcon power box. And as you see about the sizes approximately, we are talking about between 400 up to 800 kilowatt output from this unit. And the most simple setup for this is to utilize saturated steam. And that's very unique. You don't use saturated steam in a conventional turbine. There you need to have superheated, absolutely dry steam to make it work. But here we can use very simple saturated steam, up to 80% water within the steam. And that's because of our double screw turbine. We can use up to 40 bars pressure on this one. And then it's the setup as you see on this picture, with the turbine, with the gearbox, and with the generator. We can also do it without the gearbox, if that's wanted. But this setup is roughly 4 times 1.5 times 1.5 meters. So it's very compact, as you see. It's a very robust system. It operates for about 50,000 hours turbine, because before it's sent into maintenance. So about 6 years in operation, full-time operation, before any services. So it's a proven technology and a compact technology, as you see as well. With the Opcon power box, you see here an example where it can be installed. That can be, for example, in pulp or food industry that you are having a lot of here in India, as I understand. And they will make use of the excess steam in these processes and put it straight into the power box and produce electricity out of what was waste before. The other version of the power box is that we can utilize warm water for production of electricity. And then we do it with this organic Rankine cycle, as it is called, the ORC. And it works like this, that we are injecting the waste heat water, for example 70 degrees Celsius warm water. We heat exchange that and transform the heat into a refrigerant, like ammonia in this example. And this refrigerant then will evaporate at this temperature of 70 degrees. And then this vapor, this ammonia vapor, is put over this turbine again, producing electricity. And then on the other side, it's condensed back into a fluid. And therefore we need a cooling side on the other side of this. So if we are using 70 degrees wastewater on the warm side, we would like to use roughly 20 or 30 degrees cooling water on the cool side. And the cooler it can be, the better. then we will produce more electricity. So this ammonia, it's a closed loop going around like this, with a warm side, with this waste heat, and then the cooling side with the cooling. And as you see on this picture, we start on 55 degrees Celsius on this waste heat as the lowest. So from 55 degrees up to 160 degrees Celsius you can utilize in this OLC version. And as you see also on the generator power, it's in three sizes: 400, 600 and 800 kilowatt. And just to give you a hint of the flows that we need for the heat, for the hot water side, it's roughly between 100 and 600 cubic meters of warm water per hour that we want to utilize. And on the cooling side, it's roughly the double amount of water, between 300 and 1,000 cubic meters per hour. Here are a couple of pictures how it looks like for real. It's mounted in a 10-feet container, as you see. This is in the workshop where it's built up. And here it's put up in the installation on a pulp mill. So it's put in a container that can be moved into this pulp mill for utilizing, and then if we change the purpose of where you want to use it, then it's easy to move to another site. Size is 11 meters times 3 meters in this container, standard container, about 40 tons. I will now show you also some examples where it can be put in. This is a pulp mill, but can also be a food processing plant. They have excess of heat that they are putting to heat exchangers, heating coolers today before they let it out in the drain. And therefore they are consuming electricity in these cooling towers. By putting in our power box in between, then they can reduce the cooling towers. We can reduce the power on the cooling towers at the same time as we are producing new power with the power box. And I'm sure there are many good sites and examples for that in India where we could make use of the power box. Another example is to put it on diesel gensets. This can be land-based, but also in the marine side it can be utilized. But on diesel gensets, we are making use of the jacket cooling from the engine, but also from the exhaust gas that we can recover the heat from. And out of this we produce additional new power in the power box. I have mentioned these two technologies, both with a wet steam turbine for steam utilization and also for the ORC for hot water utilization. And we can also combine these two ones in a system like this to increase the electricity output. And this is made, for example, on diesel gensets, land-based or in the marine side, where we're using the jacket cooling with this ORC unit, and then we're using the exhaust via a steam boiler for steam production and use in the wet steam turbine for the power box. And here it's installed in a ship, as you can see. Some other parts of Opcon that could be interesting as well is that we are doing compressors, as I mentioned, and this can be utilized for industrial cooling, but they can also be utilized for natural gas distribution in the gas grid. It can also be utilized for biogas upgrading, where we are combining our biogas compressor, together with a scrubber. Like that can be familiar for those of you that has been working with biogas. So we upgrade the content of methane in this raw biogas from roughly 50% up to 96 or 98%, or what the design point is. And the unique thing with our biogas compressor is that this scrubbing or cleaning of the gas, the upgrading, starts already in the compressor. And that means that you can reduce the size of your scrubber. We are doing combustors as well for biofuels, for example, like wood, chips, and bark. We can combust material up to 60% with the moisture content up to 60%, very wet fuels in this combustor. It's a great combustor, moving great combustor. We can also use wood waste, for example, or briquettes, pellets, etc. So this combustor is then combined with a boiler for hot water, for steam, for thermal oil, or for some other purpose. And we do them in the sizes from 500 kilowatt up to 40 megawatt each. When combusting moisture fuels, a lot of the energy is in the flue gas that will be waste if it's just let out directly. But with a flue gas condenser, we can recover the energy in the flue gases. And it can be up to 20 to 30% of the energy input that we can recover. And in our flue gas condenser, we have a special setup for this. It's on the same time a flue gas cleaner, so we are reducing the amount of dust in the flue gas. So in the same machine, we both recover energy at the same time as we are cleaning the flue gas from dust. As you see here, we are cleaning it from 250 milligrams down to 100, or down to 20 milligrams if we are also using the wet electro filter after this condenser. This is the setup, the flue gas condenser, where the flue gas is going in, getting cleaned in the scrubber, and we recover the energy. We can put on the wet electro filter after this, if it's needed to be very clean flue gases, and then we also are cleaning the condensed water that is coming out from the condenser. But this is for moisture biofuels, that is with a moisture content of from 40% and upwards. Important is also the material handling part, where we're doing material handlings for example, for fuel handling, or for sludge handling, can be also the ash handling after combustion. We're doing this in large scale. We do it to our own equipment, but we are also doing it for other combustors, etc. So it's heavy machinery, and it's industrial standard on this. So it's very proven, reliable technologies. And interesting here in India is, of course, also the wastewater sludge handling. We're doing this in several countries with this machinery. So it can be conveyors, screws, and also sludge pumps that we're using. But this is an important part on the total setup. Of course, most of the problems, they occur in the material handling. So it's very important to have a secure and proven technology for the material handling into a power plant, into sludge handling, or some other purposes. And for today, we are searching for partnership with Indian companies for develop development of Opcon within India. And also we are searching for some initial business cases for creating these first local references that we think is very important. So I welcome both partners for long-time cooperations as well as business cases for now that could be the first references of ours. And you are welcome to our homepage, or you are welcome to contact me as well direct on my email address as you are having here. So that was a quick glance of Opcon, and now I'm open for questions, so please send in some. I've got a question here about material handling and the maximum size for our machinery for material handling. When we are talking about pellets, we are talking about wood pellets or biomaterial pellets. We are not doing anything for the iron pellets. That's another kind of machinery used then. Would be for the more simple solution with utilizing steam directly. Then we're talking roughly about $1 million US, then producing 800 kilowatts. So you can calculate the investment cost out of that. When we're talking about utilization of heat for power production, it's roughly 2.5 to 3 million US dollar for our 800 kilowatt power production. I got a question about if we have technology for coal handling for plants. And we are not doing coal handling equipment. It's for biofuels or for plastics, tires, and this kind of fuels, but not for coal handling. I also got a question about VAM, but I'm not familiar with VAM, so please describe this question once more so I understand, and I will try to give a reply. otherwise, you are welcome to send me an email later on, and I will reply to you. Yeah, I understand about the BAM now. However, I really don't follow what you are comparing with when we're talking about this vapor absorption chiller. But please send me an email on this, and I will come back to you with a proper answer on that. I also got a question about how the generators work in Indian conditions. And of course, that refers to the temperature on the waste heat you have. It's on the temperature on the cooling side. And if you just have this difference in between these temperatures, then it works as good here as in other conditions. And as it is very robust improvement systems, it works in both urban and rural areas. I can give an example on that as well if you are thinking about the warmer climate here. We are doing this in Australia. It has a similar climate to India as well. And then we have put up it on diesel gensets. It works very well. I've got a question about if this generator can be connected to the grid, and yes, it can. And I can come back to you again on an email with how it works, with how it gets synchronized into the electricity grid. And this can also be, it can also revert with this more questions of common art on the home page of the innovation accelerator. So it will be given to a broader public. We've got a question on heat recovery from a bagasse dryer, and if you are using a belt dryer, then we can make use of the recovered energy in this flue gas condenser I mentioned. We have such installations not on bagasse but on sawdust, wet sawdust from sawmills, and they work very efficient with an efficiency up to 50% recovery of the heat in the flue gases. So you can reduce your fuel consumption by 50%, or you can increase your production with a double. And I see there is some problems with the voice, but please come back to me on email, and I will give answers if it's something that was not clear in my presentation. I got a question about temperatures and the bagasse dryer, but I'm not sure that I fully understand the setup. So please send an email on this and describe the setup, and I will revert to you with an advice on that. So if no more questions, I will say thank you for your attention, and I hope I have shown some interesting areas of our technology for you, and I welcome both partners and initial business cases to contact me, and I hope that we can work out the introduction of the OPCOM technology in India together. Thank you very much.
Thank you, Dr. Rehn, from OPCOM, giving a presentation of the various technologies from the company OPCOM. OPCOM, as ClimaCheck, are seeking partners to introduce their technology in India. You can meet both ClimaCheck and OPCOM together with other innovation companies from Sweden at the virtual meeting room called India-Sweden Innovation Accelerator, innovations with an S, www.innovationsaccelerator in one word.com. Then you can also register and find a way to continue and follow up with more questions. Tomorrow, 15th of November, this delegation, the companies, also other companies in the area of solar and lightning will be present in Hyderabad. We have a full day of presentations, workshop, and individual meeting arranged by Confederation of Indian Industry. And for those of you who have the possibility, you're most welcome to meet the companies in Hyderabad, Green Building Council at CII. So thank you for your attention, and I hope we will have the opportunities to interact more in the future. Bye.